Welcome to another lab session. In this exercise, we'll be looking at FLEXURE tests. The particular test we'll be doing is a 3-point bend test, and the equipment that we'll be using in this experiment is an MTI universal testing machine. The setup is equipped with a 3-point bending test fixture with a shaft and a pin that is connected to the crosshead to apply a point load on the specimen. There are two important measurements that must be taken for this exercise. That's the span length and the cross-sectional dimension of the specimen. One should also take note of the overall dimension of the specimen. The screen that we're looking at is the MTI Universal Testing System Control. It is capable of performing a variety of tests such as tension and compression. However, today we have selected the FLEXURE test. As you can recall, in our previous labs, the machine was set to perform tension tests. With the appropriate test fixtures, a universal testing machine allows us to perform a variety of tests. As you can see on the screen, the system is set for FLEXURE tests, which can be observed here, and the particular method is a 3-point bend test. The system is set to display force versus displacement, which you can observe here. And the plot you'll be seeing during testing is a graph of force versus crosshead displacement. As you can see on the screen, the span length and the specimen cross-section are two important parameters needed for this test. So as you can see from our setup, our crosshead will be coming down, hence applying a point load on the specimen, and what we will be monitoring is the load versus the crosshead displacement. Let's proceed to test. So we would click on proceed to test and continue by proceeding. Then we would input our dimensions. And we would proceed. And then we have our display with our graph. The next step is to click run. But first, we would check to make sure that the specimen is properly aligned on the fixture. Once that is done, we can proceed. We should also ensure to have on our safety glasses. Now, let's proceed. So you can observe load and displacement, stress and strain. If you look closely, you'll see the graph. So you'll observe the load gradually increasing. Likewise, displacement. So as the load increase, our displacement is increasing, and we're getting a nice graph forming here. You will observe a slight sag in the specimen now. I can hear the specimen breaking. There we go, we're going. And you can see some distortment here. and you can see the crease in load, so we're just about ready to fracture. So with the significant decrease in load, at this point we can officially say that the specimen has failed. It's going to keep going, and the system has sensed that there's a significant decrease in load, so the specimen is failed. But I'll take the failed specimen out of the fixture so you can have a look. So as we can see, this is the failed surface. You can see failure going more than halfway through the cross section. Your typical load displacement plot. So at this point, the experiment is over and your data will be transmitted by your professor.